I've been told it's best to introduce myself when I do this sort of thing. My opinion is not necessarily any more valuable than anybody else's, but just to provide context from where my opinion is coming from, I think it's good advice, so I'm following it. So I got my undergraduate degree from Rice here in Houston. I was chemical engineering, but I spent some time doing research as an undergrad on quantum computing in Japan at Keio University. And I did some ionic liquids research with a guy named John Prosnitz at UC Berkeley. Um, Love all three of these places a lot and miss spending time at them. My first real job that wasn't R&D related outside of academia really was with this private brokerage company, CLSA, Asia Pacific Markets, and that was in Singapore and in Hong Kong. And I noticed even at CLSA that people who were able to automate some parts of their workflow really got ahead. Like some amount of research that you have to do before you interface with a client or before you present to the rest of the team is pretty rote and would require people to scrape data from websites or um, look up numbers and verify their validity based on how often they were cited in different sources and based on the validity score of those sources themselves. And that took a lot of time. And the people who were able to create systems to expedite or even automate that kind of research work could then devote more time to actually making their presentations really polished and actually analyzing the data that resulted to suggest better investments and that sort of thing. So I was already kind of like hip to and excited about this concept of using data effectively and also automating our interactions with data to whatever extent possible to speed up the process and make any individual more powerful. I then went to work for Shell and I stayed there for a while, for about 4 years. And I started off in R&D again. And then I was a technical consultant aimed outside of the company. So helping Shell's clients with mostly chemical catalysis and downstream. And then I was a software product manager, helping Shell to build software internally, as well as to oversee the software development companies that we had hired to build software for Shell. And then I became a reservoir engineer for a couple of years in Denver, and I really miss Colorado and Denver, even though it was actually a Wyoming-based asset that I was the development reservoir engineer for. I left Shell to get my MBA from Stanford, and I focused that MBA on how to help really big corporations, perhaps like Shell, to be more entrepreneurial and to empower their people to be more entrepreneurially successful inside of the company. And that was a really fun thing to study in a place like Stanford. I spent a lot of time at Stanford's D School. That's their Institute for Design, but it's not just about designing, furniture or designing physical products. There's a lot of work on how do you design business models for companies or design incentive structures inside of organizations. This is a very entrepreneurial place as well, so that was really good for me. I worked for a startup. It was a Y Combinator startup for a little bit. It was sort of my summer internship while I was getting my MBA and learned a lot about startup best practices from them, and that kind of helped me out. Then I started a company, Inly, and Inly helps big organizations to empower their people to be innovators. And so that's typically design thinking as well as technical training. And then creating the programs that then allow the ideas that come from those companies to spread and grow inside of the organization. And I also run a company here in Houston called Delphin. And Delphin is a data analytics company that helps oil majors convert their unstructured data into structured data so that way the structured data can have analytics done on it and empower people to make better decisions faster. So that's my background there. What I want to talk about in the next 50 minutes here is what I see changing about the industry. And these slides are back from the beginning of April or late March. So we're probably all pretty caught up on them, and I'll go pretty fast through this part. And then what's changing about data science. And some of us might know more about this than others. The research that I've done on this recently, I found to be really interesting. And then as a result of these two things, what can individuals in our industry do, and what can organizations do? And this part gets a little bit more, these two things are kind of, you can research them for yourselves, and it's just the data, it's just what is out there. And then these two things are more about, from my experience, what's my opinion? And feel free to react or disagree on those parts. So for this first part, what's changing about the industry? I'm going to launch into that because I'm not seeing any questions in the chat. So this is the backdrop before the recent big shocks. Let's call this blue triangle here the demand for oil products globally. And I didn't put any axes here. I just wanted to show this, generally it was increasing and has been increasing. Developing countries are still developing. Developed countries are increasing the amount of oil that they consume, generally because there's increase in more, luxury services and products and that sort of thing. So demand for oil has continued to increase, but global supply of oil is not just bigger. That's the supply, I've overlaid the demand on top of the supply. So the supply is actually this big. The supply has actually outpaced the demand, and it was growing faster than the demand. And what that was doing for the last 4 years or so was driving down the price. And because this had been going on for a while, we'd seen sort of a gradual consolidation of the oil and gas industry. Some companies were being acquired. There were a lot of new smaller operators, and then there was a lot of acquisitions as the private equity firms kind of moved around and combined things. Some of the bigger companies were laying people off, and this is Total, the company, not the total of all the energy companies. And this is just something I found from PricewaterhouseCoopers, and this is from last year, so you can see that 2016 versus 2014, headcount had been reducing, and that was already a trend. This is in percentages here. So that was the backdrop, right? And then we experienced in our industry 3 big shocks kind of all at once. The first shock, not talked about as much, was we had kind of a warm winter just now. And that winter that just finished, because it was warmer, there was less consumption than perhaps suppliers thought. And so there was more flood of supply than the demand to make up for it. And this flatter demand here resulted in kind of a stretching of that difference, driving down the price and hurting some companies. The second shock is, front of mind for everybody, COVID-19. And overnight, I heard from energy fellows at the Baker Institute that the amount of consumption dropped by about 4 or 5 million barrels in just one night. And then that continued as the service sector kind of fell apart, and people were staying home, and less travel, less movement of goods as well as people. So less demand for energy as a result, and then that drove down prices further. And then there's all this international kind of game of chicken, Russia and Saudi Arabia and the US, who's going to be producing, and OPEC kind of letting that fight escalate. I'm calling it a fight. Maybe that's not the most PC term. I don't really mean that like a war sort of fight. I just mean, if you flood the market with oil deliberately, it drives the price down for everybody and makes it harder for every operator. And the stronger, the bigger ones can survive that better than the smaller ones. So it's hurting the smaller budding companies in the US market more. So all of these things happened. And if we move this to 2020, I'm sure we've all seen this or know people who've been through this. More furloughs, more layoffs, more bankruptcies, more acquisitions, that sort of thing. So this trend was accelerated. And if we take where we started and this difference, and we compare it to the difference that we are really dealing with today, if we had just continued along in the trend that was already happening, I think we would have gotten to where we are today without actually all that much time going by. It just would have been experienced more gradually. But instead, everything was kind of like in fast forward because of those three big shocks. And so suddenly the industry is finding itself in a market environment that it was headed towards over the next, perhaps half decade or so, or perhaps the next decade. So what does this mean for companies? Well, let's say that, I have an operator and this is my break-even oil price. And so my business depends on this oil price because I'm producing oil and it's a commodity. And if the oil price is up here, then I get these. Just saw a message that says I muted myself. Double checking here. Looks like I'm unmuted. Okay, sounds like you can hear me. I might have cut out there for a minute. What I'm talking about here is this is, say, my operator's oil price that's break-even price. So if the oil price is higher than this, then I have some sort of margin of profit. And my stakeholders care about that. I care about that. My employees care about that because of the result it has on their livelihood. When the price drops below that, then every day I'm losing money. And I need to do whatever I can. If I'm a public company, I have to do whatever I can. But regardless, just to keep my company alive, I need to do something to drop my break-even price lower than that oil price so I can get those margins back. And that's really tough. That makes it really hard for some companies. So if we plot that oil price versus the ease of a company in our industry, whether they're a service company or an operator, if we plot ease of survival versus oil price, I'm not sure that this is a straight line, but it should make sense that the higher the oil price is, the easier it is for companies that are producing oil or deriving their livelihood from the production of oil to survive. So many companies were flourishing here, but when oil prices drop, only a few companies are efficient enough to still make margins from a lower oil price. So that's kind of the background. I want to start focusing on what are these companies like and what makes them different. And if they're the ones surviving and they represent the new industry, then what does that mean for people in the workforce? So I think this is all about efficiency. If everybody's oil is oil, I mean, I'm oversimplifying. Of course, there's sour, sweet, there's different kinds of oil, but it's a commodity at the end of the day. Then it boils down to efficiency in the operation. So there are a few companies that are really efficient here, and what makes them efficient? I think there's two categories. The first is scale efficiency. So I've worked with some really, really big companies, and I've worked with some really small companies that are operators or suppliers or inside of the oil and gas industry. And the really big ones get discounts. If you buy, say, 50 pieces of equipment rather than one, you might get some percentage discount. And if your operations are big enough that you can put all 50 of those to use, well, whatever that difference is in the cost is your efficiencies of scale. So if you're a bigger company, then you can afford efficiencies of scale, and that gives you a lot more operating wiggle room. You also have more cash on hand, typically, and less debt, which means that you're less vulnerable when prices change. There's also operational efficiency. And operational efficiency is something that's very much in control of the company, regardless of size. So in fact, you could even argue that smaller companies, because there's less to organize, can have better operational efficiency. There's fewer possible relationships between a smaller number of people than a larger number of people. So this is all about being data-centric here, this operational efficiency. So can you generate data? Can you organize the data that you've generated so that it's useful? And then is it actually being utilized? So think about a small operator that has two different ways of setting up a rig, for example. And why do they have two different ways? Well, because there's two different crews, and the crews have each evolved their own way of doing things. If you're generating data about what works and what doesn't during that setup process, and you organize that data and make it available to each of these two crews, then you can utilize it and discover the best practices so that the best way to set up the rigs, is the one that becomes the standard. So that's just a quick example I made up on the fly here, but I think you get what I'm talking about. So there's some overlap. There are some big companies that are also data-centric here. And I'm representing those in this darker circle that's like kind of the Venn diagram overlap here. So this mustache-looking graph, I'm calling these the efficient companies in the middle here. And this bigger circle, let's say, is the industry. If there are a bunch of companies that don't have either of those two efficiencies in this outer area here, these companies are struggling as compared to the ones in the middle. And that means that there are a lot of distressed assets that, you know, the oil is still there. There are a lot of companies, there are a lot of great people. So it becomes possible for these more efficient companies to take advantage of a situation like today's and expand. And when they do that, they'll take over these assets, they'll, you know, acquire these companies and that sort of thing. And that's what we're seeing happening. So that's what's changing about the industry. Just double checking here for questions. I can also answer questions at the very end about any of these sections. So if you're still kind of absorbing and thinking about what I'm saying here and whether you agree or disagree or what questions you have, it's not like you missed your chance. I'm going to move on to the next part, predicting that we're going to have more discussion at the end here. So what's changing about data science? This is a short section. We probably hear these things, but it's fun to look up the numbers and actually like, you know, talk about them. So data science is not a new field. And in fact, a lot of the methods and algorithms that are used in data science today that are like really sexy have existed for like decades. But it's really enjoying a popular resurgence right now. There have been what data scientists call winters in the past, where data science seemed really cool, and then it kind of became academic and nobody cared about it. And then it became really cool again. And every time it loses favor in the industry during that kind of data science market trough, we call that a winter. So right now it is not a winter at all. This is like a really big deal resurgence. So it had been kind of academic, but two things are happening right now that are really making it relevant to firms everywhere. Perhaps I could add a third thing, but I'll get to that at the end. And that third thing is that, you know, everyone's working from home, and I think that that's probably having some impact on how we're trying to get better at reskilling and how businesses are able to make decisions when there aren't people in a room trying to guess their way to a decision. So the first is increase in computing power. So this is Moore's law. This is kind of a busy slide here, but don't worry about reading all of these specific examples of computers. Notice that this is a log scale, and what we're showing here is that every 2 years, the number of transistors on an integrated circuit chip doubles, and that's kind of been true for a long time, you know, roughly, and there's, you know, outliers in either direction. But this has stayed pretty true and continues to be true, even though it continues to get harder and harder, and sort of like peak oil, people keep saying, geez, you know, we're running up against quantum barriers here. We need a big step change in how circuits are designed and how transistors are designed. And yet, you know, computers continue to get more and more powerful. And what's really interesting about this also is that it's not just about having access to processing speed that we didn't have access to before, but also that access is much cheaper. So the laptop I'm using right now is pretty cheap. I think it cost me $500. And this laptop is capable of implementing a lot of pretty sophisticated data science methods, even inside of Excel, you know, even inside of a system that wasn't really set up to handle big data. So, you know, suddenly it's democratized. That's the point, is that Moore's law has enabled people with computers anywhere, not just access to some kind of, you know, academy supercomputer, to implement these kinds of data science methods that had been more academic in the past. And we're really seeing that that's very powerful, that what people can do with data now is pretty amazing. And then the second is just an increase in the availability of data. In Texas, at least in the oil industry, this is not really part of the trend, but it sure is in the rest of the world. So many around the world are now collecting data sets, and the IDC, International Data Corporation, just a couple of years ago predicted that worldwide data would grow by 5.3 times by 2025 to 175 zettabytes, or billions of terabytes. and that more of the data sets will become more available generally to people. So 49% of data would be stored in public cloud environments. That's publicly accessible cloud environments, by the way, with nearly 30% of the data capable of being analyzed in real time. I can share these slides if people want them, so you can follow these links and kind of check on that. There's a lot of interesting predictions and theories like that. But this seems to be pretty true. If you look at the number of Kaggle competitions and how it's just ballooning, there's more and more often. And if you look at somebody's profile on GitHub, it's less likely that they're just sharing an algorithm and more likely that they're sharing an algorithm that they've tweaked as applied to a specific data set that they found that was interesting. So that's the data science part. Pausing to look for questions here just in case. So now we're going to get into the part that's more my own experience and opinion. What can individuals do about this? So remember that mustache plot that I had showed about the companies in the oil industry that are more efficient. And there was this darker circle here that had the efficiency of scale as well as the data-centric operational efficiency. And then these companies around the periphery having just sort of one or the other. And this is a really simplistic graph. Of course, it's not just both or one or the other or neither. There's some sort of spectrum here. There's probably other factors at play too. But I think it's safe to conclude overall that this is what the new industry is looking like more and more. If the companies that are in this position have comparative advantages right now, well, they're going to exploit those comparative advantages and increase their footprint, increase their total market share. And that's what's happening, with acquisitions of assets and acquisitions of companies and, sniping really good people and that sort of thing. So if this is the new industry, the question becomes, how should I, spend my time appealing to these companies that represent this new industry? So what do these companies want from me and people, like me? And how can I then stand out from the crowd to appeal to companies like these? And I think there's two things that these kinds of companies want from individuals. The first is, same as ever, experience in the industry. If you take some, hotshot data scientist fresh out of a master's degree from a really nice school, or some self-taught, whiz who, has been putting together software from a basement for, 10 years, but is still a teenager or something like that. Those people can be very valuable, but they're not going to be able to hit the ground running in oil and gas unless they have oil and gas experience to complement that. And I've seen this firsthand because I work with a lot of data scientists. On two levels. I work with them directly in my own company, people who don't come from the oil industry and whose creativity in oil industry context and whose ability to understand at a high level how to process data and therefore how to set up infrastructure to process oil and gas industry data is somewhat handicapped by their lack of experience there. And we have to work with them, coupling them with people who have the experience to make sure that the processes that emerge are really fit for purpose and that sort of thing. But also, people inside of oil companies, a lot of the oil companies are now hiring data scientists. And the concept of the unicorn is somebody who has some sort of data experience, but who has a lot of industry experience and knows how to put that data to use. So having the experience in the industry really matters. But the data-centric skill set really matters too. And this is starting to matter more and more. So my argument is that people in this position who have the experience can become those kinds of unicorns actually pretty quickly. But it's much harder for people who have just a background, say, in straight software engineering to immediately kick butt in the oil industry. So I've seen one go to two and be much more effective than I've seen two go to one. Doesn't mean it can't happen either way, but I really like the 1 to 2 philosophy there. So how do you do that? Like, what is the data-centric skill set? This is really my opinion now. Like, we're getting into myself thinking about my own experience. I've worked with companies in the oil industry for sure, but I've also worked with companies like Intel or Starwood Hotels and Resorts, Sheraton, those kinds of companies. And so I think that this what I'm talking about here applies more generally than just the oil and gas industry. I think one big part of it, and this is often overlooked, is this innovation acculturation. So especially in traditional organizations, we can get to feeling like if we know how to do our job based on the job description and based on our predecessor who came before us, we're pretty valuable. And I think that's less true now. Sure, that's the starting point, but you need to always be thinking about how you can create a step change in your own workflow, and how you can revolutionize the way that your work has been done in the past. So if you're always looking for opportunities and sizing them up and trying to come up with creative ways to add new value, then you've got this innovation acculturation box checked. The next is data driven. So there are a lot of creative people, but just being creative on its own in a vacuum isn't going to lead to innovation. It has to actually work. It has to be better than the firm's existing best practice in whatever the context is. So how do you prove that it's better? Well, you have to capture the right data. So you have to know what data to capture and what data to pay attention to. So that means you have to define a problem pretty clearly and back that problem up with data, so that then if you come up with something that you can test against it, you can have something compelling to show that perhaps you're on a path towards innovation. Next up, you got to be project oriented about this whole thing. So if you don't know how long it's going to take you to gather data, and if you don't know what sort of expertise you need to help you in your endeavor, you can wind up wasting a lot of time trying to put together a project that you should have shot down from the beginning because it would take, I don't know, 20 years or something to implement. So getting project oriented is also really important. And then finally, and this is the part that I think a lot of people shy away from, even though it's really like becoming easier and easier, is being software proficient yourself. And I mean software engineering, like being able to build your own software, even if it's just a script in Visual Basic to automate some part of your workflow. If you know how to script something, if you have some familiarity with code, then you get much more project oriented because you know how hard it is to do something. And you don't just have to rely on, a forum that you read online and extrapolating from that forum to predicting how hard it would be to create a new piece of software that might lead to some sort of innovation. You could actually propose a coherent plan to your management. And so these four things working together, I think, comprise the data-centric skill set. And typically, Inley is hired to generate all four of these things, even if they're phrased differently from the client side, before the people are really capable of not needing Inley anymore and continuing to do this on their own. And I think the places to start with these two things are on the ends, the kind of bookends here. So if you start learning about software, that's great. But if you just learn about software in a vacuum, you become kind of like a software manual, if you have a real project that you can apply it to, that's much better. And how do you come up with a project? Well, if at the same time that you're learning about software, if you're also learning about design thinking and need discovery, that's a really good way to get going here, because you'll start to think of projects and you'll have these inklings or fledgling ideas about what might constitute a worthwhile project. And as you're learning the software, it'll stick a lot better because you can relate it to your idea about how to make some sort of meaningful change in the industry or inside of your workplace, or maybe in a new industry. And then that leads to these other two skills. These two things are worth learning directly on their own, but they're things that they kind of come in context when you've done more innovation acculturation and software proficiency first. Cool. I'm just going to react to this comment because it looks interesting. So Raphael is saying, I might be being rude right now, but I believe that data-centric skills are receiving the real value now. As you mentioned, the industry received lots of shocks. Yeah, in the last 5 years. Before that, automation and data science inside the industry was walking as a turtle. Yeah, so I don't think that's rude. I mean, it sounds like we agree with each other that the industry has been shocked and that automation and data science was kind of moving more slowly before than it is now. Yeah, I mean, there are still plenty of companies that I see and work with that for whom this is sort of new stuff. These are like new topics to talk about. And there are a lot of individuals that I have, dealt with in those companies, or people who are in transition right now, looking for how they can adopt skills like this, because up until recently this wasn't like a front of mind thing in the industry. You know? So some specific examples here: software proficiency. I'm talking about, like, can you learn Visual Basic and Python? SQL is popular too. There's a whole bunch of things like this. Python is great. It's grown to become the most popular software scripting language in the world in almost every context. And there's lots of cool libraries for oil and gas. The reason why I put Visual Basic on here, Visual Basic for applications, is the scripting language that works with Excel. It's just because the oil industry has the vast majority of its data still stored and manipulated inside of Excel. So a lot of the workflows that individuals are involved with have to use Excel. You have to take your input in the form of Excel, and you have to share your output, whatever that is, with the next part of the workflow in Excel. So if you know Visual Basic as well as Python, that's kind of where the rubber hits the road, and you can do some really amazing things. You know how to set something up using Visual Basic quickly, port it to Python, do something in Python, send it back to Visual Basic or back to Excel, that sort of thing. So just some quick examples. For the project-oriented stuff, you've probably heard of Agile and Scrum. There are these kind of more official methodologies here. But just generally, if you come up with a project and you can think about, like, how long would it take, what kind of help would you need? And the more realistic you are, the more correct you are when you put these kinds of predictions together, the better you are at being project-oriented. Data-driven, here's a couple of very powerful and now more and more popular machine learning methods that help with data science initiatives. But there's a whole laundry list of these. There's tons of them, and there's new ones too. And then there's the innovation acculturated stuff. I mentioned design thinking. I'm a really big fan of that methodology. If you don't want to be as methodical about it, just look at startups and hang out with startups and see how they spend their time and what they're working on. And maybe offer to try to help on the side, or maybe you can use your industry expertise to give some advice to startups. But the startup culture kind of is similar to the design thinking culture, and perhaps less formal, but you learn a lot of the same stuff there. And then what can organizations do? I'm going to pause here for another question. I mentioned that oil and gas stores their info in Excel, which is correct. I'm curious, how do other industries store their data? Is there a better way? Yeah, so one of the challenges of Excel is that even if you use the version of Excel that is cloud-based, that's native, like on the cloud rather than stored on your laptop, there are still challenges to scaling, and there are still challenges to processing. So I think there's like a limit of 1 million cells in Excel on Microsoft 365. And that sounds like a lot, but if you start to think about, what if you want all of your data from your whole company in one place where people can pull what they need and manipulate it and derive some sort of value from it? Maybe there's a lesson in safety that is a data-driven lesson that came from drilling, but also applies to the completions teams. Should that be siloed in drilling, or should it be accessible to completions teams? You start to wind up with a lot of data to look at, and if you can organize it into a different backend aside from just storing it in Excel, then that's good. So SQL is typically the first step, like, away from Excel, but there are lots of other ways to do that too. Oil and gas has huge amounts of data. That's true, and that's an opportunity as well as a challenge, right? Like, there's potentially a lot more to learn, which implies that perhaps the amount of efficiency improvement in oil and gas can be bigger than in some other industries that are more traditionally straightforward, like logistics or shipping. If I run a shipping company, I've got, who do I ship with, where does it need to go, what's the cargo, what are the laws? But oil and gas is like, it's like NASA. It's super complex. We've got tons of a wide variety of subject matter experts, each with their own really deep expertise, working on a much bigger engineering process overall. So lots of data. My experience is, I'm quoting here from Lori, my experience has been that people are trying to figure out what can be done with it, but failing to be project-oriented because of the hype about data science giving you something for nothing. Yeah, just stuff the data through calculations and you get answers. Yeah, one of the problems I see with that, the hype, is people get excited about the specific method, you know? Um, like there's this hip thing called a neural network, and everyone wants to, oh, dude, let's do a neural network and we'll get all kinds of value in our company. But the data isn't ready for that. What are you going to put into your neural network that are comparative features of, labeled samples? A lot of folks, like by the time you've hired your neural network experts and set them up to create value, only then do you realize that you're not ready to do that yet because your data isn't ready for that. And you have to spend a lot of time finding and cleaning the data, and you need to involve, along with those neural networks experts, you need to involve the people who are actually driving the business and represent the teams that are core to business, so they can help inform what sort of data is erroneous and what should be included, and what would constitute helpful if it was an output from a neural network. There have been a lot of instances I've seen where even though the data was clean, the product from the data science team, that was a new team inside the organization or even a consulting firm, was something that was actually obvious and was well known by the operator to begin with. And that doesn't mean that the data science couldn't have added value and that it only gives you obvious results. It's just that the people who were doing the data science didn't know what the unknown unknowns were. So you kind of have to like experiment and get everybody on board together. I think that's a really good point, Lori. So what can organizations do? I'm just going to do an experiment here, and maybe we can write what we think our answers are in the Zoom chat. So which is the right culture for oil and gas? I'll lay out two cultures here. The first one is more consensus driven. So we develop and we follow strict standards, and we do all of our thinking before we act rather than, as a reactive sort of organization. And we try to avoid the iterative processes and creative risk taking that some other organizations, make more part of their central culture. That's option number one. And then option number two is more individual focused. We're iterating quickly and creatively. So we try stuff, and if it doesn't work, oh, well then, that gives us some idea about what next thing that we could try. The only reason that we really think ahead is because we're trying to save time. We're not too worried about trying stuff and then reacting to it otherwise. And we avoid analysis at all, really, before we've generated any data to analyze. So that means that we tend to scoff a little bit at precedent, and we're looking more at, I don't care what was impossible in the past, I'm going to try something new, and if it doesn't work, I'll look at that data to try to convince myself why and what I could do instead. So I'm going to learn more from my failure. Do we think that culture number one or culture number two is more appropriate for the oil and gas industry? I'm just curious what people think here. 1.5. That's clever. Yeah. I put in one myself. One is where we've been for decades. Yeah. I think one is still the predominant culture, and it deserves that. And the reason why I say that is, if we do culture number, let's say we're designing, it's a huge civil engineering, electrical engineering, probably there's chemical engineering, there's certainly petroleum engineering, tons of geoscience, all of these kinds of disciplines into building a beautiful rig like this. This is the kind of thing that got me into oil and gas. I think this is incredible. Look at this thing. If we did that in like this second culture way, hey, we learned from our failure. Yeah, but the consequences of failure were huge, right? People can get hurt. We lose a lot more money if there's higher CapEx projects because it's hardware, not software. This culture traditionally, the second culture, doesn't work very well for oil and gas. I think that's still true. We need to be very careful, and we need to be process oriented and safety oriented overall. But I think that there are places inside the company, and there are certain times inside the company, even for more conservative, generally parts of the organization. There are places and times where this kind of culture should predominate. So we need pockets of this culture inside of otherwise something like this. And that's pretty hard to do. I don't know that I've ever seen it work perfectly, but I've seen some cool examples. Um, I can think of a couple. So, which is the right culture for adaptive software? Um, and I think that, you see this in Amazon and Google, and Google is becoming a really big company in terms of people and process. But certainly in the early days, and I think Amazon is still like this, a lot of tech companies that are software native companies, they never had the risks of CapEx waste that the oil industry did. If something goes wrong, maybe a server goes down, right? Whereas in oil and gas, not only do you lose money potentially, but you hurt people and you hurt the environment, and the general public hates you when you mess up. So you got to be a lot more careful. But when you try to build software as an organization and make it competitive, when you're in this kind of in this kind of culture, it becomes way harder to do that as compared to this culture. And there are now opportunities for individuals inside of the company to build software. So gosh, what does that mean? How do they wear two different culture hats at once? And when do they take off one and put on the other, and that sort of thing? I think that's why it's harder and more complicated for oil and gas. So coming back, I asked the question, what can organizations do? But I wanted to do a caveat there and talk about the cultural challenge, because I think that's a big part of it. And it's not like, it's not like oil and gas is full of, people who don't, read the news or don't see that this stuff exists and don't care about other industries or have decided deliberately not to embrace new technologies. I think there's a reason why oil and gas is said to lag in the digital transformation kind of stuff. And I think that's because of culture largely. So what do I think organizations can do? The first thing I'd say is train people. I think that's really important. Like, I'm shocked that training budgets were one of the first things cut when, the most valuable asset in the company are people with experience. Subject matter experts, especially with firm specific skills, generate so much value inside of a company because a lot of their skills are, really valuable just to that company. And if they leave the company and go to another company, they can't take all of that value with them, which means that even though they're paid a lot, they're not paid so much more because they could otherwise just go to another company. You get a lot more incremental value from your subject matter experts. And a lot of these people are really, really good at learning new software, as it turns out. And not just software, I think learning to think in an innovative way, like a startup is totally possible. So training people is a good thing, but then incentivizing innovation. And I think these things go together here. So you want to train your people, but so what if you've trained them? You also want to empower them to use their training to actually make a difference on the job. And some ways I've seen this work in the past, if you have, say, upside inside of your oil company, and I've seen this in pretty much all the majors and some of the independents, that's pretty small. Like, if you do an exceptional job this year, you get an extra $1,000 at the end of the year or something. That's not very exciting to people. If tenure is still the main way to move up in terms of pay and power in the company, then you're not really encouraging people to focus on things other than maintaining the status quo and waiting. But if you give people an incentive to measure the status quo, prove that, arrive at consensus about what it is, and then try to make it better. And when you compare it to that status quo that's measured and agreed on, if it is in fact better and that's proven, then you give them a big reward, and that's commensurate to the value that they've created. That's huge. That's a really big deal. You can also train or incentivize people to take risks. And as long as they take educated risks that aren't risking the livelihood of the company. When I say take risks, I mean try an idea in a controlled experiment that's not, the oil rig falls over, but more like, I spent 3 days exploring this new model that I thought might fit our data better. And it turns out I'm wrong. But here's how I proved that I was wrong. And here's what would have to change about either our data, the situation, or the model in order for that model to become more relevant. Well, hey, add that to the innovation library. That's valuable. Reward that employee for having done that. And I've seen that kind of behavior rewarded outside of this industry more than inside of it. Make data available. This is a really big one. You got to have data accessible to people if you want them to use it. And I've noticed that's true inside the company as well as outside the company. If you go to places like Colorado, where there's a lot more of a culture of publicly sharing data, what you discover is that people in the workforce have more experience with and are better at scraping data from, competitor websites or from government websites, and are better at, using data analytics to process that kind of data. And it makes sense because they have access to it. So you got to give people data to work with, and that, internally you can think about how are different P&L groups working together. And I actually have a little case study about that I'll share in just a second. Ought to take about 2 minutes. And then finally, make IT enablers. So IT gets a lot of flack, especially right now, for holding back innovation. And I don't think that's totally fair. I don't think that IT is like full of people who are, out to shut down projects because they're bad people and they don't want their company to be successful. Of course not. I think that it's all about the incentive structure. Traditionally, IT in oil and gas is about giving people the hardware that they need and the software that has been proven to work in the past. And then on top of that, to be a cost center that makes sure that no data is breached and that, the oil company doesn't lose money or get in trouble because they've shared data that they shouldn't have shared. And the easiest way to make sure that doesn't happen is to say no to any sort of project that involves sharing data or, using external entrepreneurial help or external uh, consulting help. And that strategy doesn't work, that incentive structure doesn't work very well for IT anymore, especially since if you work with a startup, probably that startup is not storing its own data in its own cloud on its own servers that are more likely to be hacked or more vulnerable to hacks. They're probably storing them on the same, Amazon or Microsoft Azure or whatever that you're using. And then if it's stolen or hacked, it's not the startup's fault. You can go after Microsoft and you can sue them for everything that your data is worth for sure. So the risks have gone down. The likelihood that data is breached has gone down. And the likelihood that even if data is breached, that the consequences of that breach are really bad for you, that's all gone down too. So, IT kind of, the incentive structure needs an overhaul there. And you want IT to still be in charge of figuring out what the possible risks are, but then also to help enable the project, even though there's risks. And you can create incentive structures that allow that to happen too. And when that happens, that's great. I saw that a little bit with a few firms. I think EOG is really good at that. Working with startups, trying out startups, their new products and services in carefully controlled projects, and making the IT is very careful about, like, well, here's data that can be shared to try that, and then once it's proven, here's how we mitigate the risk. So that kind of thing can happen. So here's a quick case study from another industry. So Twitter. Turns out there were two parts of Twitter that were categorizing different tweets. There was one group that wanted to see what kind of tweets are inappropriate, and there's another group that wanted to see what should we advertise to our people. What kind of ads should we serve? So, and they were trying to categorize based on topic, like are we talking about oil and gas, or are we talking about the latest movie or whatever? By style, so how is the tweet written? Is it inflammatory, or does it have curse words in it or something? And then by intent, what's the point? Are they trying to recommend something? Are they denouncing something? Whatever. And this team, the security team, that's not the right way to say it. I guess the appropriateness, measure team had figured out a really good way, and that categorization was working very well. And the other team, the ad team, was like, hey, we think you're doing this well. Can you give us your technique so we can use it over here too? And it's a separate P&L group, so there's no motivation traditionally for the first team to spend time helping the second team. It's valuable to them, but the reformatting that's required is pretty significant effort. And so the way that Twitter handles this kind of situation rather than try to make all of the data science a completely top-down system, they found that bottom-up works better if you give the individual people who have individual kind of contributions to their workflow, if you give them an incentive to try to make their own workflows better using data science, and if you invest in training them, then you get better results. But then how do you overcome this problem where, you know, one system is sprouted that works well on a small scale inside of one team, but it really needs to be firm-wide implementation at that point because it could be useful to another team. Who's going to do that work? The way that they set it up is they made this internal data marketplace. It's really cool. So if you have data and you know, some kind of special organization method that another team wants, you can strike a deal. So you can make a deal with that advertising team and say, all right, we'll spend X% of our people's time over the next few months making this system span not just our, but your workflows. And then we get closer and we know each other's workflows better. That's a side product that's beneficial. But in exchange, you need to spend some of your time helping us figure something else out. Like perhaps people who click on certain ads, are they more likely to post inappropriate content? That sort of thing. And then management helps to oversee and broker these deals. And that keeps management more informed on what's working and what isn't. Because, you know, you're not just listening to one team say that it's working. You now have that verified by another team with no incentive structure, you know, like there no incentive to be to spin that as though it's better than it is, right? So management can stay on top of what's working pretty well inside of that. So that's all that I had prepared today. Just a quick recap. The two groups of four, this is what I think really works well for companies. So you got to train your people, incentivize the innovation so that the training matters. And you got to make data available so they can actually implement it. And then they need to not be shut down by traditional roadblocks inside of the company. And what are they getting trained on? Well, that comes back to these four things: the innovation acculturation, the software proficiency, and then being data-driven and project-oriented. So you can apply that innovation, and you know how much time and what sort of expertise is needed. So I know that was a lot, and I went pretty fast. I love this stuff, and so if you give me more time, I'll just talk forever. So when I have less time, I try to spread it out, but I tend to just condense a lot of material because it's fun for me. I'm going to stop the share just for a second so people can see me while I'm answering questions. I notice a few more have come in. Big companies don't even want to share data internally between different business units. Yeah, I think that's often it's the business units that don't want to share. You know, for example, one of the companies that is one of Delphin's clients, they are, there's a group that we helped in one part of the company, and the way that we helped them is pretty valuable to another part of the company. And so we said, hey, can you introduce us over there so we can help that other? That's how we want to grow, is team by team, implementation by implementation. And the answer was like kind of no, because we got to get credit for it first. We want to show off to the company overall that we figured this out and it works really well for us. And then we can kind of share it around so that, you know, we want the credit to come where credit's due here. And if we shared you with the other team right away, then, you know, and I guess that kind of makes sense, right? It's not that the people are bad or that the company is, you know, unsuccessful and doesn't deserve to thrive. It's just like, it's about the incentive structure there. And it's about when does management start to pay attention to whether something is working or could work. And it sounds like it's a lot further along on the path to success than maybe it could be. And as a result of that, one downside is that this other team isn't going to get exposure as quickly as they could to something that worked really well for another team. 100% says Lori. Oh, sorry, says Daniel about Lori. Yeah. And then give individuals incentive to short circuit managers. I have to think about that. I guess it depends on the context. You know, there's always that Patch Adams lesson, right? I don't know if you guys have seen that movie. It's kind of an old one where, like, if you're having trouble with your manager, but you really think you're right, can you take it one level above your manager to the next level up? It's kind of risky, right? Because your manager is your manager, but, you know, maybe there's a way that you can that you can bring it up to the people above where it's not your manager's fault and there's no ill will. It's just about, hey, is this a good idea or not? Somehow I'm unconvinced that it's a bad idea. And if it gets some traction, then maybe the way that that's communicated down to the team doesn't step on anyone's toes or make anyone look bad. I'm not very good at those kinds of like company politics things. So I don't know if you should take my advice on how to do that. But yeah, I mean, there's definitely a challenge if the way traditionally that you move up in the organization is not by trying to be more innovative with data, but is by trying to do what's been done in the past, regardless of data. If that's the way that traditionally you move up, then the people who are in control of how things are actually going to work are people who are going to think that way, and that's a challenge overall. So it's 101. Nobody, of course, is obligated to stay on this call. But I will for more time if anyone else wants to discuss more. Yeah, thank you everybody for joining. I care about this a lot. Part of the reason why I care about it a lot is because my own livelihood is connected to this stuff. Inley is teaching programs to oil and gas people, trying to empower this data-centric skill set. And Delphin is trying to empower this data-centric skill set to matter by helping to organize the unstructured data that's already inside of the oil companies. So if you want to check those two things out, that's Inley's website, and then that's Delphin's website. Oh, thank you for saying thank you. Yeah, I really appreciate everybody joining. Fazal. Data QC is key for any business. Yeah. 60% of time is spent cleaning data and making honest way for, in my experience. Yeah, and I've seen that stat, Mofazal. I'm sorry if I'm mispronouncing your name. I've heard from Equinor that it's 80%, 80% of time is spent looking for data, cleaning it up, and getting it ready to then start doing your value-added workflow. And imagine if you have a PhD and 20 years of oil experience, your time is worth a lot. And if you could spend 100% of your time actually implementing with the cleaned data that's at your fingertips, at least for that individual, that's a huge improvement. From 20 up to 100 is a 5x improvement on their contribution to the company potentially. So there's a big efficiency gap there to close. I agree.